Good morning, students. On today's lecture, this is my second video of solving this question paper, Additional Mathematics Paper 2, 4037, Variation 21, May, June 2018. In last of my video, I have finished up to 5, and from today, today I'm gonna solve from question number 6. Okay, this is a circular measure. In the diagram, A, OB, and DOC are the sector of center O, and the angle AOB given x radian. The length of AB, this length of AB is given 40 centimeter, and the radius OB, the bigger one, the length given, whatever the arc length is given over here, its radius is given 16 centimeter. It says find the value of x. Now we know that arc length equal to r theta in radian. Okay, now arc length is given 40 and radius is given 16. So what is theta? So theta equal to 40 divided by 16. You can take the calculator and find out the value. Okay, and it should be given you 5 by 2. So you can write down 5 by 2 or 2.5 radian. Okay, so that's the answer for this one. Find the area of the sector AOP. Now, area of sector, and its formula is half r squared theta in radian. Okay, I just want to check that. No, you don't have that formula given. Okay, so you have to memorize this. So half, and what is r? R we got here 16. See that? This 16. AOB, the bigger sector's radius is 16. So 16 square, and what is theta? Theta was 5 by 2. So I can use the calculator to find out that 16 square divided by 2 times 2.5. I got 320. This is in centimeter, so square centimeter. So that's the sector of this one. Now, given the area of the shaded region, this shaded region A, B, C, D is 140 square centimeter. Find the length of OC. Now, OC is the smaller radius. Okay, so I can replace that by, what do we want? I want let it be small r. I haven't used r anywhere, so I can use, actually I did. So let's put that A. Okay, so according to the question, area of ABCD, I hope you can see that area of the bigger sector minus area of the smaller sector, that gives me shaded area. So area. So I can say area large sector and minus area small sector. Okay, that is given 140. And this one, area of the larger sector, we got 320. And this is going to be theta. We do know the value of theta. Okay, area again, half r squared theta. So let's put that. And this r is A. So A square. And then theta is 5 by 2. Okay, so bring this to this side is going to be 5 by 4A square. And this is going to be 320 minus 140. That's 320 minus 140 gives me 180. And A square, 180 times 4 divided by 5 times 4 divided by 5. I got 144. Therefore, A, we know that is a perfect square, 12 centimeter. So OC equal to 12 centimeter. Okay, so that's that. Okay. All right. Now we're gonna go for the question number 7. Differentiate with respect to x. So dx of 4x tan x. Okay. Now this one is we need to use the product rule. So to do that, I'm gonna do 4x ddx of tan x plus tan x ddx of 4x. You could have just do directly. Okay, I usually do directly. 4x and tan x differentiate. If you differentiate it, it's going to be sec square x plus here tan x and this is going to be 4, so I can write down 4 over here. So that's done. Okay, now again this one, dx of e to the power 3x plus 1 divided by x square minus 1. That one was product rule, this is the quotient rule. So you can write down denominator is going to be x square minus 1 whole square and x square minus 1, and differentiate that. So it's going to be e to the power 3x plus 1. I'm doing directly, and then differentiate that again. So it's going to be 3 minus, you're going to keep this one, e to the power 3x plus 1, and differentiate that. That should be 2x. Okay, so my differentiation is done. You can keep the answer is like this, or sometimes you can just simplify that a little bit. What do I mean by that? See that e to the power 3x plus 1, and over here you have 3 e to the power 3x plus 1. You can keep, let me show you what can you do. E to the power 3 e to the power 3x plus 1. This is x square minus 1 minus 2x e to the power 3x plus 1 divided by x square minus 1 whole square. You can keep this one as it is, or you can take this part common, this and this. No need, again no need, because 3 marks you already have done enough work. E to the power 3x plus 1. So over here you're gonna end up with 3x square minus 2x, and this is minus 3. I hope you can see that. X square minus 1 whole square. Sometimes we need to do that so we can cancel out the denominator and numerator. Okay, so either one, this one or this one will do. Okay, so that's done. Question number 8. An experiment was carried out recording values of y for certain values of x. The variables x and y are thought to be connected by the relationship y equal to ax to the power n, where a and n are constants, so that cannot be fraction or decimal. Transform the relationship y equal to ax to the power n into the straight line form. If you look at here, okay, see that this is an exponential function. Power is there. It's in the form of exponential function. So what you can do, you can change this one to log or natural logarithm, common logarithm, or any other base or base e natural logarithm. But when you look at this, it's ln. So I need to take ln on both sides. So take ln y equal to ln ax to the power n. And you know that when it's multiplied, it's actually added. So ln a plus ln x to the power n. So we can rewrite that y equal to mx plus c in that format. So ln y equal to, that's gonna be n ln x plus ln a. Okay, so that's done over here. Okay, the values of ln y and ln x were plotted. Some of the values plotted in the line of best fit drawn. This is shown in the diagram below. Okay, use the graph to find the values of a and n. We're gonna see this. Ln a is that ln y intercept. Okay, this one is, this particular thing is ln y intercept. Okay, and this n is the gradient. Okay, and we represent that by m most of the time. So we need to find out this a, that one, not ln a but a and n. Now n, we need to find out n. We know that gradient is the difference of y axis over x axis. So when I look at this best fit graph, always better to take this first value and the last value. And the first value, because its x's value is 0, and this one 4.1 2 3 4 5 6 7. So 4.7, that's what I got. And the last one is 8. X's value is 8, and here is 2 1 2 3 4 5 6 7. So 2.7. Okay, so n or m, or in this case n is going to be difference in y-axis. So 4.7 minus 2.7, and below here 0 minus 8. So 4.7 2.7, that's going to give me 2 minus 8, that's going to be minus 1 by 4. Okay, so that's my n, and then that's n, yeah, that's n. And then y equal to mx plus c, and I'm going to use this one. Y is going to be 4.7, m I got minus 1.4, and x is going to be 0, plus c is going to be ln a. Okay, so this is 0, ln a equal to 4.7, therefore a equal to e to the power 4.7. Okay, you can keep it this way because it didn't say into decimal place or whatever, but, or you can do 4.7. It's gonna give you approximately 109.94 so far, or you can write down correct to three significant figures 110. It's up to you. Okay, I would have keep it this way. Find the value of x when y equal to 50. Okay, now this one it didn't say from the graph, so I checked the equation. Okay, or this one y equal to 50, so 50, and then we have a, we got 109.9, then x to the power n is minus 0.25. Okay, so x to the power minus 1 by 4 equal to 50 divided by 109.9, and then this is gonna be, actually if I take this one over here, x to the power 1 by 4 equal to 50 109.9, and that's gonna be x 1 by 4, and this is gonna be 109.9 divided by 50 and power 4, so this is gonna be x. Okay, so 109.9 divided by 50 to the power 4, and I got 23.3, correct to three significant figures. You can do it this way, or you can put the value of y over here, ln 50, then n's value over here, then ln a's value over here, and you can calculate x. Okay, but this is another way you can do this. Okay, now express 5x squared, question number 9, minus 14x minus 3 in the form of this. This is completing the square. Okay, so from this 2, wherever I have x with the terms that has x in it, I'm going to take common p. So coefficient of x squared, that's 5 taken common. So this is x squared minus 14 by 5x minus 3. You can take the bracket off and you multiply that. It's going to be 5x squared, 5 cross out, minus 14x. So actually I'm not changing anything. 5 over here, I'm going to do a square minus 2ab plus b square. I'm doing the completing the square. So this is x. So a square minus 2ab plus b square. This thing comes over here and this thing goes over here. So this x gonna come over here, 2x. Now this is already equals to that. Now I'm gonna match with this minus, then I have 2 on the numerator, I need 14. So 7, and denominator I need 5. So that 2 times 7 is 14. Let me do this with 2. So 2 times 7 is 14 by 5x. So that's okay. And this thing gonna come over here, 7 by 5. So this equals this. This whole thing equals to this. This one I have written extra. So I need to subtract that. Okay. And then minus 3. You can see that all of them are equal. Okay, that's equal sign actually. This 5, this equals to this equal to that. I wrote this extra, I subtracted that. So that's basically 0, and that's that. Why did I do that? I did this because this whole thing form quadratic format. Okay, quadratic equation in the format of this one. That's minus. So it's minus b whole square. Or let me write down that a minus b whole square. So that can be written as x minus 7 by 5 whole square. Okay, and this one, when I take it the bracket of 5 minus 5 times this one, this is going to be 49 by 25. That's cross out 5, and over here minus 3. So this is going to be 5 x minus 7 by 5 square, and this is going to be, look at this, minus 49 by 5 minus 3. That's going to give me minus 64 by 5. So that's my final answer. Okay, completing the square. Okay, sketch the graph. Same graph. Okay, sketch it. Now this one is my whenever I have that, okay, if I have a x square plus bx plus c written in this form, a equal to x minus h square plus k, then this h and k is the either maximum or minimum point depend on a. If a is greater than 0, this is the minimum point. If a is less than 0, then this is going to be the maximum point. Okay, so a is over here 5 and that's greater than 0, so this is going to be minimum point. So what is 64 over 5? Okay, 64 over 5, that's going to be 12.8. That's negative 12.8. So go over here. Let's say this is 5 minus 5. That's minus 10. That's minus 15. And this one is 7 by 5. That's about 1.4. So take that 1, 2, 3. And over here minus 1, minus 2, minus 3. So 1.4 somewhere over here, and that one was 12.64 divided by 5. That one, okay, let me write down that 7 by 5 equal to 1.4 minus that gonna be positive, and this one is nothing but negative 64 by 5. That's gonna be minus 12.8. So 12.8 somewhere, let's say over here, that's my minimum point. And then I need some values that intersect this x-axis. Okay, on x-axis y equal to 0. I'm just gonna go for this equation and find out where when y equal to 0, when this one equal to 0, y equal to 0, what is the value of x? Just to show you that so I can draw it clearly. I'm going to use the calculator and 3 quadratic form. A is 5, B is minus 14, C is minus 3. So I got x equal to 3, and another one is minus 1 by 5. Okay, so minus 1 by 5, that's going to be minus 1 by 5, that's going to be 0.2 minus 0.2. So somewhere over here, and that's going to be another one is 3, is right over here. Okay, the graph's supposed to be, this is a quadratic graph, that graph's supposed to be something like this. Okay, something like that. You can see that some of the part I have just did the broken line or dotted line because there is a modulus sign. So this one will be reflected on this one. Remember the point over here, it was 1.4 minus 12.8. So when it's reflected this, so that's going to be 5, that's going to be 10, that's going to be 15. So it's going to be somewhere over here. And this is going to be 1.4. And instead of minus, it's going to be 12.8. So this graph will be actually going like this. And then this is my modulus sign. Okay, that's that. Okay, if you do the pencil, if you draw this with the pencil, you can erase that. Okay, so that's done. State the set of values of k for this one equal to k has exactly 4 solutions. Now I'm gonna show you with this scale over here. See that if this is the line, okay, if this is the line over here on y, if it's over here, see that, think about this. Okay, if the line is here, then it's not intersect with that, so 0 solution. If it's on x-axis, then there are 2 solutions. If you go over x-axis, then 1, 2, 3, 4. Okay, you go more. Exactly when you are at x equal to 1.4, then there are 3 solutions. 1, 2, and this is the tangent. And go up, it's going to be only 2 solutions. So I'm just going to draw this to show you. Okay, that and this part over here. Okay, over here you have 2 solutions, and over here you have 3 solutions. Okay, and on the top it's going to be over here is 2 solutions only. Okay, but you need 4 solutions. So any line in between over here is 4 solutions. So k is going to be, this k is greater than 0 because on y-axis, on x-axis y equal to 0. So it's going to be greater than 0. And this value, what was this value? This value was this one. Okay, that one was 64.5, this particular value. So it's gonna be 64 by 5. Okay, so if k is in between this value, this equation gonna have 4 solution. Let's say, let's show you one of them. If this is 5, okay, this is 5. If k equal to 5 over here, okay, so that equal to 5, so y equal to 5, you can see that there are 1 solution, 2 solution, 3 solution, 4 solution. Okay, so we are okay. Don't give this answer. Okay, just this is just an example. So k is going to be greater than 0 but less than or equal to 64 by 5. All right, let me do the question number 10, 11 and 12 in my next video. Okay, see you later. Take care. Bye.